Welcome to a new episode of The Power Talk, the official podcast powered by ROHM Semiconductor Europe. My name is Katrin Hases-Schmidt. I'm working as a content marketing manager at ROHM Semiconductor Europe. Today's topic revolves around the safety inside cars. Mainly, we will answer the question where exactly ROHM's hidden champion semiconductors are applied in the so-called Advanced Driver Assistance Systems, abbreviated ADAS. My guest today is my colleague Michael Maurer, Senior Application Marketing Manager at our company. Michael has been working as an engineer and technical marketing manager for over 30 years already and has filed 10 patents so far. Since almost 2 years, he is working for ROHM Semiconductor Europe, where he has been very prosperous as well. For example, he has given several online seminars about electronic-related topics to provide a special service to our customers. Also, from my personal perception, he is a well-respected colleague and a reliable contact partner in terms of various types of technical questions. Michael, first of all, thanks for being my guest today. Looking at your Vita, you always seem to have a special connection to the automotive industry, with a special affinity to advanced driver assistance systems. Could you tell us more about your fascination for this field, please?
Hey Katrin, many thanks for the invitation. Always a pleasure talking to you. ADAS is a very interesting and challenging field of application, and most of the necessary technologies were always a side of my career. Starting with hardware designs, today necessary to understand customers' detailed questions and concerns, software development down to machine level. This is requested for optimized, best-fitting PMIC drivers, and you have to understand software-based functions down to bit level. Project management, very important discipline to plan and execute projects in time with the requested content at agreed cost. Telematics, the combination of telecommunication and informatic. On this, I have learned a lot when I was working for a small company named Lab. Here I furthermore experienced the combination of telematics, sensors and actuators, very similar to ADAS applications. Last but not least, the more than 15 years experience in the semiconductor industry, where I was working with the largest processor vendors in close cooperation with system and processor architects. ADAS, or Advanced Driver Assistance System, is the combination of at least all these experienced parts in my career. So it becomes clear that I have to work in this automotive application sooner or later. Beneath the close cooperation with the customers, it's always very important for me to communicate exactly to the designers and the application teams.
The key advantage of ADAS is to improve safety by preventing accidents. Could you please provide us with some concise example on how ADAS assists drivers to ensure greater safety?
Yeah, nice questions. Let's start with a very simple example, the parking assistance. Today, there are multiple systems available, starting with ultrasonic solutions, systems via cameras and also radar. The effect, the parking damages, is expected to be reduced by around 10%. A more advanced application is the emergency braking. Here, cameras and radar systems operate in a so-called sensor fusion application, means multiple sensor signals will be used for environmental risk calculation and classification, and finally the ADAS ECU will take the decision to brake in order to avoid an accident if the driver is not attentive enough or too slow. There are multiple other ADAS applications like lane departure warnings, adaptive cruise control, blind spot detection, pedestrian detection, traffic sign detection, and even more, each designed to reduce the risk and improve the safety for the traffic participants.
In this context, Where do ROHM's product solution come into play within ADAS?
A very interesting question. As I've tried to explain, ADAS is the combination of sensors, actuators and software running on extreme powerful processors. Traditional vehicles have a typical 12-volt car battery. High-voltage electrical vehicles a DC-DC regulator system providing a 12-volt supply net. Sensors and processors will request very challenging supply voltages, and today we can see a clear trend to lower voltages and higher current, especially for the processors. In order to reduce the design effort for the Tier 1s, we are offering integrated power supply solutions called PMICs, power management ICs, that provide multiple power supply voltages with dedicated power supply sequences in a single chip. Furthermore, we are currently adding functional safety features into the PMICs to ensure proper operation at any time and inform safety processors if abnormalities are detected. Today, we are offering companion chips supervising supply voltages and provide watchdog function to check the software sanity, but as mentioned, in future such functions will be integrated. As of today, the focus for PMICs was on sensors and processors, but we will optimize this approach and will offer power solutions which are flexible enough to address applications. A next step into a highly integrated world, which will become also simple to use for the engineers.
The topic of autonomous driving is discussed more and more. Do you think it could become reality soon that our car drives us while we sleep or read a book? How reliable is such a technology from your point of view?
What a complex question. Regarding the timeline of full autonomous driving, it will be easier answering your question on reliability first. The ADAS functions needs to be bulletproven. Otherwise, OEMs and the subcontractors will run into liability issues and no company will ensure full autonomous driving cars. Reading books or lying back while driving, you can do it as a passenger, not as a driver, at least for the next, let's say, 5 to 10 years. According to the references, the level of autonomous driving is split into 5 categories. Today, we are at a level of 2 with functions like autonomous parking, lane departure warning, automatic braking, following function. According to the literature, these functions should have been implemented between 2015 and 2022. Decide by your own on the reliability and usability of such functions if included in your car. The next step will become much more complex for the software, and especially in the mixed traffic where autonomous driven cars will be in the same traffic with the human driven vehicles. There will be a lot of challenges. Just one point to think of: the computer follows the rules. Is a person doing so? I think in 5 to 10 years there will be the first in volumes autonomous driven vehicles on the highway, on dedicated sections with proper marking where the driver is allowed to fully release the steering wheel and relies on the computer. Then probably you can read your book unless the insurance companies will block. As an alternative, lanes will be reserved for autonomous driven vehicles in order to reduce the risk of accidents.
Which other promising trends are on the horizon related to ADAS?
This is hard to answer, Katrin, but looking inside the magic crystal ball, I can see full autonomous driving trucks with no driver on board, starting at the main terminal and driving in truck convoys to other terminals located far away. Here the trucks will be taken over by drivers and maneuvered to its final destination. Such kind of ADAS application could be seen in reasonable time frame, will reduce the fuel consumption, reduce the risk, and furthermore reduces the cost of transportation.
Michael, thank you very much for this truly inspiring talk. I'm very excited to see which of these ADAS trends will prevail in the future.
Yeah, very challenging field. Looking forward into the future. And Katrin, it was nice, as always, talking to you.
Thank you very much for being my guest today.
You're absolutely welcome.